Well, hi everybody. Now that you have understood the meaning of the differential of y, we're going to do some applications of it. So if you look at the notes, you're going to see that we have an example number 2. I'm going to copy the exercise. Well, the exercise says to estimate the value of the square root of 50. If you think of the square root of 50, that will be 7 point something decimal, because 50 is a very close number to 49, which has an exact square root. So the question is, what is the function that we want to work with? Well, I'll show you. So we want to estimate the square root of 50, which is close to 49. So the function would be y equals the square root of x, because we're looking for the square root of 50. What will be the values for x and the value for the differential of x? Those values will be 49, which is the closest number to 50 that has exact square root. And the differential of x is going to be 1, because that's the difference between 50 and 49. Now, how are we going to do to find out or to estimate the square root of 50? Well, the square root of 50 equals the square root of 49 plus some decimal that we're going to write as the differential of y. Now, let's recall the definition for the differential of y, which equals the derivative of the function times the differential of x. So we're going to need the derivative of y, which is square root of x, and then we're going to substitute the differential of x, which equals 1. Now we're going to organize the information. We have the function square root of x, and its derivative f prime of x would be 1/2 times x to the negative 1/2, which equals 1/2 times the square root of x. So now we have the derivative. Again, the definition of the differential of y equals f prime of x times the differential of x. Now we're going to substitute the values. The derivative equals 1 over, I'm moving this. There we go. Okay. The derivative of the function equals 1/2 times the square root of x times the differential of x. Now, substituting the values, we're going to have 1/2 times the square root of 49 times 1. And that will be 1/14. Now that we have the differential of y, which equals 1/14, we're going to find the approximation of the square root of 50, which equals square root of 49 plus the differential of y. And that will be 7 plus 1/14. You can find the decimal number for 1/14, or you can just leave it like this, because this is a good approximation of the differential of y. If you want to find the decimal for this number, all you have to do is to divide 1 by 14, and then you're going to find the decimal. So this is how we use the differential of y to estimate the square root of 50. Now we're going to work with another example, which is sine of 31 degrees. If you remember from trigonometry, sine of 30 degrees has an exact value, which is opposite side 1 over hypotenuse, which equals 2. So we know now that the sine of 31 degrees is approximately 1/2 plus certain decimal number, very small number. And we're going to call that number the differential of y. So we're going to use differentials to estimate the value of sine of 31 degrees. But before we start with this function and all the calculations, I would like to recall some important stuff for this example. So what I want to recall is that 30 degrees can be written in radians, and that will be pi over 6 radians. So the sine of pi over 6 radians equals 1/2. I'm going to draw here a rect triangle that has 30 degrees here, and here we have the 60-degree angle, and then we have the rectangle. The opposite side of the 30 degrees angle equals 1, and then the hypotenuse equals 2, and the adjacent side equals the square root of 3. I want you to keep this in mind because we're going to need the cosine of pi over 6, which is 30 degrees. So the cosine of pi over 6 would be adjacent side, square root of 3, over hypotenuse, that equals 2. So we have sine for 30 degrees here, which is 1/2, and cosine of 30 degrees, which is square root of 3 over 2. We're going to need this information to estimate the value of sine of 31 degrees. So we want to estimate the value of sine of 31 degrees, right? So this is approximately equal to the sine of 30 degrees plus one small number that we're going to write as the differential of y, because the differential of y is the estimation. Now, what is the function? The function f of x is going to be sine of x, because we want to find the sine of 31 degrees. Now we need the derivative of it because we need it for the definition of the differential. The derivative of sine of x equals cosine of x. And then the definition for the differential of y equals f prime of x times the differential of x. And we're going to substitute. Now we're going to have the differential of y equals the derivative of the function, which equals cosine of x, times the differential of x. Well, we're going to calculate the differential of y. The differential of y equals cosine of x, but the value for x will be cosine of 30 degrees times the differential of x, which is 1 degree. But we have to write degrees as radians. So we want to find the cosine of pi over 6 radians. And then, even though I don't like it, we're going to have to calculate 1 degree as radians. And you're going to have to do that by using your calculator. I don't like it, you know that, but we're going to need it for this example. That's 0.01745. So cosine of pi over 6 equals the adjacent side, which equals square root of 3 over 2 times 0.01745. So if we do this product, as I said, using calculator, we're going to obtain the number 0.01511. So the differential of y equals 0.01511. 0.1511. To finish this exercise, let's write the final conclusion. We said at the beginning that the sine of 31 degrees would be approximately equal to the sine of 30 degrees plus the differential of y. So the sine of 30 degrees equals 1/2. And the very small number that we found for the differential of y is 0.01511. So the sine of 31 degrees is approximately equal to 0.5 plus 0.01511, and that would be 0.51511. So that's how we use differentials to find some approximations. I hope this video is being clear enough to you.